Let's move on to the third keynote presentation, which will be delivered by Dr. Vijay Swarup, who is the Vice President of Research and Development at ExxonMobil. The title of his keynote presentation is Developing Our Energy Future. Dr. Vijay, please.
Thank you. Thank you very much for the introduction, and it's certainly an honor to be here. Let me see if I can share my screen. Okay, how's that?
Looks good.
Okay, that may be the scariest part of this entire ordeal. So again, thank you so much for the invitation, and it is an honor to be part of this program. I will tell you, I'm calling in from New Jersey in the United States. So again, I appreciate you accommodating the time difference and allowing me to participate. And before I get started, I just hope everybody's doing well. I know this the conditions under which we're working continue to be a challenge, but certainly hope everybody's doing well. And again, it's a real privilege to talk to you, and it's a real privilege to come on after the three speakers that we've heard so far. I think they were the right combination of optimism, the right combination of speaking about the challenge, and also talking about the fact that we need some technology. And so what I'd like to talk about in the next 5 to 10 minutes is ExxonMobil's approach to developing the energy future, put the problem in a bit of a different context, and build off of what we just heard from A-Star. By the way, congratulations to A-Star for the announcement that was just made. But I want to build off of what was said there around, well, how do you actually speed or enable the innovation that's required, particularly at the scales that energy requires? Now, we've talked about this already today, but just to put it in context, and I like the previous speaker who said, well, the first thing you have to do is, what's the question? We need to answer a question, but we need to spend some time understanding the question. So we call this the dual challenge. What does the dual challenge mean? On the left-hand side is a very simple graph that shows the UN Human Development Index on the y-axis and energy consumption on the x-axis. And the trend is clear. Quality of life, Human Development Index, correlates with energy consumption. And that shouldn't surprise anyone. You can see the blue dots are the developed nations, the US, Norway. Red dots are the developing nations, Bangladesh, Nigeria, India, etc. And you can see that as you move from lower left to the upper right along that arrow, you can see that energy consumption goes up. Now that shouldn't surprise anybody, because whether we realize it or not, energy is all around us, sometimes taken for granted by those of us that live in developed nations. But this entire conference is enabled by energy. The internet, the Zoom videos, the computers, everything is energy. And so as you move up development, access to washing machines, televisions, cars, all those things require energy. So the case is clear. Energy is required for quality of life. Now, the question is, how do you provide that energy? And the second part of the challenge is we want to provide that energy while reducing or while managing emissions. Now, to answer that question, you have to break that down to, where do the emissions come from? So we heard already from today that the majority of emissions do come from something tied to energy. Well, what I show here are the four key sectors that contribute to the emissions. You can see them from power, electricity, industrial, that would be steel, cement, refining, chemicals, transportation, anything from cars all the way to ships and airplanes, and then finally residential, commercial, the buildings in which we work, the houses in which we live. All require energy, therefore all have emissions. So on the left-hand side, you have the first part of the problem, which is you need a geographical overlay, multiple variables there, because each geography, we're talking about the unique challenges to Singapore. Every country will have unique challenges. For the large countries like the US, the challenges can become even at the state level, or at the city level. So you have to have the geography correct, and then you have to understand your emission sources. So what starts off as a dual challenge, two variables, actually quickly becomes multiple challenges. And as you dig into this problem further, it becomes clear that what is needed here is technology. And that, of course, is the theme of today's meeting, is how are we going to develop the technologies? And just to put that in context, this is some work that the IEA did. We've already heard some references to the IEA. This is work that the IA did, looking at the technologies that are required to meet the ambitions of the dual challenge and which ones are on track. And you can see by the colors, red, green, and yellow, you can see the 34 of the 40 needed technology areas are currently not on track. Now, 6 are on track. So let's start there. And those required innovation. 34 are not on track, will require technology to close that gap. And that technology covers the spectrum from innovation to development to scale. And as the previous speaker spoke to this, one of the comments he made was, how do you do this differently? He called it the valley of death. But the question that he posed, which is a very good one, is how do we go about addressing technology development such that we can deploy faster? I'm not convinced you can invent faster. It is very hard to put a timeline on invention. What you can do to inspire invention is define the problem, which we've done, define the problem at a sub-level and a sub-level and a sub-level, which we're trying to do. So regionally, by sector, and now if you look at this slide, even by the technology that's not on track. And one could argue that the further the technology is from being on track, the more room there is for innovation, the more room there is for deploying at speeds and scales that we haven't seen before. Now, how do we do this? The previous slides showed the TRL levels, and it showed the middle, which was deemed to be the tough part, where you go from discovery, you're not quite at scale, how do you get to deployment? Now I'm going to talk about how ExxonMobil thinks about this. And again, above, from discovery to deployment and scale, you see a very linear approach. You discover, you develop, you have a first deployment, you have development and scale. Now, if you dig a little bit further into that, you'll see that, along that pipeline, different players play different roles. Now, the discovery, the fundamentals, the core concepts, those are often done at universities. And I list there several leading universities, energy centers that we belong to, like Singapore Energy Center, also universities in Europe, Stanford, MIT, etc. Also, I list on there IBM. IBM is developing quantum computing. We talked about the need for supercomputers and the speed of digital. Quantum computing can take that to a whole new level. That discovery, those discoveries that can enable energy solutions, is really vital. And it's important that we continue to inspire and work very closely with those that are working on that front end of the pipeline. Of course, that's one of the reasons why we're so engaged with the Singapore Energy Center. Now, the next block is development. How do we do that? Again, the previous discussion around test beds and how do you get to that next level of scale, critical discussion. In the US, we have national labs. And I list there some of the national labs that we work with, because that is one way to speed up the development, to be able to test things at different scales. A-STAR and what they just talked about, critical to that. And if we can get innovative, modular-based test beds that can do multiple technologies, very important, because that will also speed up development. Third, now you're ready to deploy. Well, what we're finding is smaller companies can deploy faster. And so what you see here, Viridus, formerly known as Synthetic Genomics, that's our algae partner. Global Thermostat, we're working on direct air capture. Fuel Cell Energy on carbon capture. That first deployment is critical. That first deployment gets you on the experience curve, gets you on the learning curve, gets you on the scaling curve. So you can go from discovery to development to first deployment. And then finally, companies like ours bring the capital, bring the project expertise, bring the knowledge of scale to take these things to scale. Now, do that in series, A to B to C to D, probably the longest time. Do that in parallel, which was we're postulating here. Work with the universities, work with the national labs, work with the A-STARs, work with the smaller companies, the Viridus, the Global Thermostats, the innovative companies that have technologies that are ready for first deployment, but do that with line of sight to scale. That's the key. And so as we're doing the work with the Singapore Energy Center, we are constantly talking about, what is the fundamental understanding we need to be able to take this to scale? When we're working with national labs, when we're working with others that can do that, the development, what are the critical variables? That first deployment, What are we doing here in terms of scale? Is it numbering up, meaning we have to build more of these? Is it scaling up, meaning we have to make it bigger? Those fundamental questions all help enable deployment at scale. And if done in parallel, we think can help speed up the pathway to scale. That's the key here. How do we get these technologies on the pathway to scale? That's what we're working on. And the key, the word that's been used a lot today, and I think will be continued to use through this workshop, collaboration. How do we change collaboration? How do we challenge the paradigms of collaboration? And that's what we're showing here. Now, what I'd like to do, though, is come back to the energy centers. We have a long history with working with universities. We've been working with universities, for decades. At any given moment, we're working with several, 50, 70, 80 universities. But we also work with energy centers. Why do we work with energy centers? Two reasons. One, the previous slide. They can help us advance technologies that we're interested in taking to scale. But two, it also widens our aperture and it lets us understand where the science is going. And it helps us understand the breakthroughs that are happening in the adjacent technologies that we may not be working in, but we need to be aware of because they help define the energy landscape of the future. So what you can see here is by sector again, power, transportation, and industry. Some of the universities we're working with, and the areas where we have focus areas to understand emissions reductions. And not surprisingly, you can see the broad list, but if I talk about Singapore, and we're very excited to be a founding member of the Singapore Energy Center, we have a great relationship there. Clearly the technologies that already been talked about, carbon capture, hydrogen, building materials, new materials, and how do you do separations? How do you take energy intensity out of the energy industry? 4 key areas that we're working on with the Singapore Energy Center. We're very, very excited to be part of this. We've already heard about the 18 projects that are up and running. We heard about the call for new proposals. That is what we need to do. We need to continue to look for the ideas, working with the professors, working with the students to help come up with more ideas. This is a problem that requires technology to solve. It requires multiple technologies. We need more options. And universities are a very efficient place to work at getting those solutions and those options. So I want to get to the Q&A and I want to talk more as we go through today. It's very exciting to be part of this. I think we have to start with the humility and also with the inspiration that the current technology can't meet the dual challenge. That's what we're here to talk about. How do we accelerate those technologies? Now, companies like ourselves, long history in research, long history in technology, long history in working collaboratively, and a long history of scaling up energy solutions. We're talking about doing things in parallel rather than in series. We're talking about collaborating at levels we haven't collaborated at before. All those things are going to help solve the dual challenge. And finally, if we're going to do those two things, we have to start with the basics, deep science and engineering. That is the essence of why we work with energy centers. That is the essence of why we participate in events like this. And it's critical that we have the types of discussions that you're fostering today and the over 200 people that are attending today. Just shows that the passion is there, the interest is there. We need to harness that energy, that power, and try to drive it towards these solutions. Again, it's an honor to be included today. It's an honor to be part of the Energy Center, and certainly look forward to the rest of this event. And I'm happy to take questions if there are any. Thank you.
Thank you, Dr. Vijay, for the very insightful keynote, especially the importance of working collaboratively, right? So that we can actually do the scaling up and to basically translate all the wonderful deep science and engineering, the research outcomes into deployable solutions.